Today's lesson is 1.3.1, Part 2, Graphing in Slope-Intercept Form. And our objective is that students will be able to graph an equation in two variables using slope-intercept form. So we have a few vocabulary words that we're going to start out with today. And the first vocabulary word is slope. And our last lesson was all about slope, so this word should not be a new word to you. Slope is the steepness of a line, and it is represented by the variable m. And we can find our slope by calculating the rise over the run. Our next vocab word is y-intercept. The y-intercept is the y value of the point where the line intersects the y-axis. So we always have points that, or an ordered pair is always listed as x, y. So your x value in the y-intercept is always 0, and then your y value is going to change depending on where it is being intersected. And in terms of graphing, the y-intercept is typically your starting point. So slope and the y-intercept are the two most important parts of graphing linear equations. Our next term is x-intercept. X-intercept is the x value of the point where the line intersects the x-axis. So our example here is x. This value is going to change depending on where we're intersecting. And then the second value will always be 0 in place of our y. Our next term is solution. When we're talking about linear equations and graphs of linear equations, and we talk about the solution, we are referring to any point in the form x comma y, so any ordered pair that falls on the line. And our final vocab word, it's not really a vocab word, it's more a formula. So let's go to the next page for that. So our formula is slope-intercept form. And this should be a formula that you used in math last year as well. But we'll do a quick little reminder of it. That formula is y equals mx plus b. So in this formula, we have two values that will be substituted with something else. That first value is the m right here. And when we went over our vocabulary, we mentioned that m is slope. The second value is b right here. And b is the y-intercept. In fact, I'm going to go back to the previous screen, and I'm just going to make a note right over here that y-intercept is represented with b. So you'll want to add that to your y-intercept vocabulary. Just remind yourself y-intercept is represented with the value b. Okay, so we've already gone over slope. There are two special graphs that I do want to mention. The first one is our horizontal graph. So in a horizontal graph, that is when we have a slope that equals 0. When slope equals 0, that means I have a horizontal line. If you need to review that, you can flip back to your last notes. So let's go ahead and draw a coordinate plane here. And if I were to have the equation y equals -2, what that equation tells me is that all of my y values are going to equal -2. So I have this coordinate plane here. When x is 0, my y value is going to equal -2. So I'm going to go down here to -2, plot a point. When x is 3, y is -2. When x is -3, y is 2. When x is 4, y is 2. You can see that y always equals 2, and if I were to connect all of these dots, it would just give me a horizontal line. So anytime you see an equation that says y equals and then just a single number, that is going to be a horizontal line, or it's going to have zero slope. The second special graph is a graph that goes straight up and down, and this is going to be when our slope is undefined. Okay. And an example of that would be x equals 4. So let's go back to drawing another quadratic plane. And 1, 2, 3, 4. So it doesn't matter what my y values are. My x values here are always going to equal 4. I have a 4 where y is 0. I have a 4 up here, 4 down here, 4 down here. Anytime we have an equation that says x equals in just a single number, that is going to give us a horizontal line, or sorry, a vertical line. And as we know from our previous lesson, a vertical line has no slope. Now let's learn how to graph other lines. So for our first example, we have a slope of 3 over 2, or 3/2, and we have a y-intercept of -5. Your first step to graphing a line in slope-intercept form is to identify the slope. We know that the slope is represented with the value of m. We also know that the slope equals the rise over the run. Well, over here I have my slope, m equals 3 over 2. So that 3 tells me that I'm going to be going up 3. 2 tells me I'm going to be going over 2. So I know that my slope here is 3 over 2. My second step is to identify my y-intercept. Well, when I look over the information that I was given, for example, number 1, I see that b equals -5. And I already know that the y-intercept is represented with the value of b. I'm just going to go ahead and do one other thing. I'm going to write that as a point. So we know that y-intercept always has an x value of 0, and the y value is that -5. My next step is to plot the y-intercept, which I'm going to abbreviate with int. So I'm going to go over here to my coordinate plane, and we're going to need to count up 1, 2, 3, up to where y equals 3. But that's not right. Our y value is -5. So we're going to go down to 1, 2, 3, 4, 5. Down here where b equals -5. And I'm going to go ahead and I'm going to plot a point right there. Okay. Next, my fourth step is to plot 2 more points using slope. So when I say using slope, I'm going to use the rise over the run. So let's make a little side note. If my rise is a positive number, that means I'm going to go up. If my rise is a negative number, that means I'm going to go down. if my run was a positive number, I would go right. And if my run is a negative number, I will go left. So we've identified our slope as 3 over 2, which means the rise is 3, the run is 2. So I'm going to go down here and I'm going to count up 1, 2, 3. That was up 3 from my positive rise. And then over 1, 2. That's moving over 2 to the right because I have a positive run. So 1, 2, 3 over 1, 2. And that's my point. Well, it told me to do that twice. So from that second point, I'm going to go up again. Up 1, 2, 3 over 1, 2. So I now have 3 points. I have my y-intercept. I have my first point from going up 3 over 2. And my second point from going up 3 over 2. Now, our fifth and final step is to connect the points using a straight line. This is a linear equation, and linear means line, so they are going to increase with a constant rate. So we will go through our dots and draw as straight of a line as you can through those dots. Make sure we put arrows on each end because linear equations go on forever. This is going to continue going down to negative infinity. This is going to continue going up to positive infinity. So we've got our 5 steps here. Let's look at a couple more examples. So our second example to look at is y equals negative 2x minus 3. This one is a little more tricky just because we have our information presented to us as a linear equation rather than just being told what m equals and told what b equals. So number one is for me to identify the slope. Well, if you go back, we know that slope-intercept form is y equals mx plus b. Let's go ahead and rewrite that underneath example number 2. So slope-intercept form, y equals mx plus b. Our slope is always the coefficient of x, and our y-intercept is always the constant. So if I identify my slope, I'll see that it is this m value right here. I'm going to write that as negative 2 over 1, just because I know that the slope has a rise and a run. So my rise is at negative 2, my run is the 1 that's underneath the negative 2 that we can't see right here in the equation, but it just doesn't change the value of the number when we write it here below. Step number 2 tells me to identify the y-intercept. My y-intercept is right over here. It's the constant. And I need to include that negative. So my y-intercept is negative 3, or I can write that as a point, 0, negative 3. Step 3 is to plot my y-intercept. So let's go down 1, 2, to 0, negative 3. Step 4 is to plot 2 more points using slope. So I'm going to start here at my point and count down 1, 2, over 1 to the right. Notice that I went down 2 because of that negative in front of the 2. And then I went to the right because the 1 is positive. So I went down for negative, to the right for positive. From here, I'm going to continue going down 1, 2, over 1 to the right. And we could continue this process of going down 2, over 1 to the right, and you would see that it makes a straight line. So for my step 5, I connect the dots and form this straight line that's going to go on to negative and positive infinity. Now, you only have to do 3 points. You don't need to do all these extra points that I just did here. I want you doing a maximum of 3. Let's look at one more example. All right, for our last example, we have a clean graph to look at. So step number 1 is for me to identify my slope. Right over here, I see that my coefficient is -1/5, and I know that my coefficient represents my slope, or the m value. Remember, y equals mx plus b. So m equals -1/5. My second step is to identify b, and b equals a +4, which is the same thing as the 0.04. Step number 3 we know is to plot our y-intercept. This time our y-intercept is up at +4. And then our next step is to move on to the slope. Since my slope is a -1/5, that means I'm going to start at my y-intercept. Always start at the y-intercept. I'm going to go down 1 and then over 1, 2, 3, 4, 5 to the right. Make sure you're going down 1 instead of up 1 because of that negative number. Now, you could go down 1 and over 1, 2, 3, 4, 5 again and form a point, but I want to show you a different way to do it. So let's say your graph kind of cut off right here, and you didn't have enough room to go and do another point over to the right. So you have to go up to the left instead. Well, I just went down and right. The opposite directions would be to go up and left. So rather than going down 1, up 5, or down 1, right 5, I'm going to start at my y-intercept again, and I'm going to go up 1, and then to the left 5. 1, 2, 3, 4, 5. When we connect those dots, you'll see, hopefully if I can draw a straight line, yes, it still forms a straight line. If I would have continued over here at that point and gone down 1 over 1, 2, 3, 4, 5, it would still fall on that line. And the dots would continue falling on that line, whether we go down 1 over 5, 1, 2, 3, 4, 5, or if we go up 1 and left 5. The points should still continue on the line. Now, my line here is not the straightest line, so it's not perfect, but you can see that the points are falling on that line. Tomorrow we will be practicing graphing by using M and B, and also by taking the points right out of slope-intercept form like we had to do on our last 2 examples. Make sure you take your quiz so you can get credit for this lesson, and go ahead and rewatch anything else that you may need to go over again.